Hello everyone, welcome back to my channel Explain Maths. Now in this video, I will be covering the important questions of Exponent chapter from R.S. Aggarwal and Exemplar. So I have taken a few questions from R.S. Aggarwal also and from Exemplar also, and I have solved it over here. So let's begin the class. Question number 1. By what number should minus 6 whole to the power minus 1 be multiplied so that the product becomes 9 to the power minus 1? So we know that in such type of question, what number to be multiplied, divided, added or subtracted, what we assume? We first assume let the number be x. So here I will assume let the number to be multiplied be x. So now what I will write from here? I am going to write minus 6 whole minus 1 multiply by x, and it says when you multiply it, it will become 9 to the power minus 1. Now I'm going to use the law a to the power minus m equal to 1 by a to the power m. Okay, so this will become 1 by minus 6 multiply by x equal to 1 by 9. And to get the value of x, I'm going to transpose minus 6 to the other side. So it will be minus 6 by 9. Let's reduce it. So 3 times 2 is 6, 3 times 3 is 9. So the number to be multiplied is minus 2 by 3. Question number 2. By what number should minus 2 by 3 whole to the power negative 3 be divided so that the quotient may be 4 by 27 whole to the power minus 2? So here also I will assume let the number to be divided be x. So it will become minus 2 by 3 whole to the power minus 3 divided by 4 by 27 whole to the power minus 2. So what I am going to do from here, as here x is divided, I am going to transpose it to the RHS. So division will change to multiplication. So it will be minus 2 by 3 raised to the power minus 3 equal to 4 by 27 whole to the power minus 2 multiply by x. Okay, and I can use the law a by b raised to the power minus m. Okay, this is equal to b by a whole to the power m, right? So I'm going to use that law over here. So it will become minus 3 by 2 whole cube equal to 27 by 4 whole square multiply by x. And I have to get the value of x from here. So what I will do, I will transpose 27 by 4 whole square to the other side. So multiplication will change to division. So minus 3 by 2 whole cube divided by 27 by 4 whole square. Now minus 3 cube will be minus 27 and 2 cube is 8. Now I'm going to change division to multiplication. So it will become 4 square by 27 square, right? Now next what I will do, minus 27 divided by 8, 4 square is 16, divided by 27 square I am writing as 27 by 27. So I am going to reduce it. Now 8 times 2 is 16. So from here I will get my answer as minus 2 by 27. Now this is one way of doing. Other way, you can convert here 4 as base 2, 8 also as base 2, and you can use laws of exponent and you can solve using that way also. Okay. Question number 3. Find the value of x. This is the first question. 5 by 3 raised to the power minus 2 into 5 by 3 raised to the power minus 14 equal to 5 by 3 raised to the power 8x. And you have to find the value of x over here. So if you see the LHS base is same. So you have to add the power. So it will be 5 by 3 whole minus 2 plus minus 14. And this will be equal to 5 by 3 whole 8x. Okay. Now we know that when base is same in LHS and RHS, then exponent will also be same. So from here I can write, now minus 2 plus minus 14 will give me minus 16. Now minus 16 is equal to 8x. So from here we can write the value of x will be minus 16 divided by 8, which will give me minus 2 as the answer. So the value of x is minus 2. Now moving to the second question. Negative 2 whole raised to the power 3 into negative 2 raised to the power minus 6 equal to negative 2 raised to the power 2x minus 1. Again, if you see in the LHS, base is same, so you have to add the powers. So it will be minus 2 whole 3 plus minus 6 equal to minus 2 whole 2x minus 1. Now again, if you see in the LHS and RHS, base is same, so you have to uh, when base is same, we know that the exponents will also be same. So from here we can write 3 plus minus 6 is equal to 2x minus 1. And 3 plus minus 6 will give me minus 3 equal to 2x minus 1. So which will I can write as 2x equal to minus 3 plus 1. And minus 3 plus 1 is minus 2. So from here I can write my value of 2x is equal to minus 2. So x will be minus 2 divided by 2, which will give me minus 1 as the answer. Okay, now moving to the third question. Now here in this question, 2 to the power negative 1 plus 4 to the power negative 1 plus 6 to the power negative 1 plus 8 to the power negative 1 and whole x is equal to 1. So we will use here negative exponent law, which tells that a to the power minus m is equal to 1 by a to the power m, right? So I'm going to write it here like that. 2 to the power negative 1 is 1 by 2 plus 1 by 4 plus 1 by 6 plus 1 by 8 and whole to the power x is equal to 1. Now the LCM of 2, 4, 6 and 8 is 24. So I'm going to take the LCM. So LCM is 24. So it will be 2 times 12 is 24. So it will be 12. 4 times 6. 6 times 4 and 8 times 3. This whole x is equal to 1. And if I add it, I will get 25 by 24 whole x is equal to 1. Now we know that any rational number to the power is 0, right? So what I will do, I am going to write 1 as 25 by 24 whole raised to the power 0. Now why I have written 1 as that? Because I have seen that my LHS is having a base of 25 by 24 and I have to get the value of x. The value of x we can find if my base is same, because when base is same in LHS and RHS, then only exponent will also be same. So to make the base same, I have written 1 as 25 by 24 whole raised to the power 0. So the value of x will be 0. Clear? In question number 4, I have to find the value of m. And if we see here, in the numerator, the base is same, right? Base is 5. So I am going to use the product law. So product law tells that if a to the power m into a to the power n, that will be equal to a to the power m plus n. Okay, so here I am going to write 5 to the power m plus 3 plus negative 2. So I can use this law for 3 numbers also. That divided by 5 to the power minus 5 is equal to 5 to the power 12. And if I add it, 3 plus minus 2 will give me 1. So 5 to the power m plus 1 is divided by 5 to the power minus 5, which is equal to 5 to the power 12. Now I am going to use the division law, because if I can see in the numerator and denominator, my base is 5. So the division law tells that a to the power m divided by a to the power n is equal to a to the power m minus n. So I will use here 5 to the power m plus 1 minus of minus 5 will be equal to 5 to the power 12. Now we already know that when base is same in both LHS and RHS, my exponents will also be same, right? So in LHS and RHS, if you see here, base is 5. Here also LHS base is 5, RHS also base is 5. So power will be same. So from here I can write m plus 1 minus and minus will become plus equal to 12. So it will be m plus 6 equal to 12. So from here the value of m will be equal to 12 minus 6, and 12 minus 6 is 6. Question number 5. A newborn bear weighs 4 kg. How many kilograms might a 5-year-old bear weigh if its weight increases by the power of 2 in 5 years? So it is given that the newborn bear weight is 4 kg, right? And it is given in 5 years the weight is increasing by the power of 2 from the current weight. So current weight is 4 kg. In this, it is increasing by power of 2. So the weight of the bear will be 4 square because it is given that the weight is increased by power of 2. So 4 to the power 2 is 16 kg. So the answer is 16 kg. Now question number 6. The cells of a bacteria double in every 30 minutes. A scientist begins with a single cell. How many cells will be there after 12 hours and after 24 hours? So here it is given that the cells of a bacteria in the beginning is 1. And then there is a condition given that in every 30 minutes it gets doubled. So double of 1 is 2. So it means after 30 minutes it will be 2. Now again double of 2 is 4, right? So in 1 hour it will become 2 square. Now same way if you have keep on uh, calculating it, so in each hour it is getting increased by 2 to the power 2. So if you have to find number of bacteria in 12 hours, so first hour is 2 square, second hour is also multiplied by 2 square, then third hour, fourth hour, fifth hour, sixth hour, seventh hour, eighth hour, ninth hour, 10th hour, 11th hour and 12th hour. So if you can see here, 2 to the power 2 is getting multiplied by 12 times. And we know that repeated multiplication is exponent, right? So this we can write as 2 square whole to the power 12 because it is getting multiplied 12 times. And then if you use power law, 2 into 12 will give me 24. So number of bacteria in 12 hours is 2 to the power 24. Now to find number of bacteria in 24 hours, we are going to follow the same pattern. If it is 12 hours, 2 square is getting 2 square is having a power of 12. Now if you have to find for 24 hours, so 2 square will have a power of 24 and 2 into 24 is 48. So number of bacteria in 24 hours will be 2 to the power 48. Now question number 7. Planet A is at a distance of 9.35 into 10 to the power 6 kilometer from Earth and planet B is 6.27 into 10 to the power 7 kilometer from Earth. Which planet is nearer to the Earth? Now to find out which planet is nearer, we have to compare their distance. Whichever distance will be less from the Earth, that planet will be nearer, right? So it is given here, planet A distance from Earth is 9.35 into 10 to the power 6 kilometer. Planet B distance is 6.27 into 10 to the power 7 kilometer. Okay, now I am going to compare it. But how to compare? The power of 10 is different. If the power of 10 will be same, then easily I can compare these decimal values, isn't it? So what I will do, I am going to write this 6.27 into this 10 to the power 7. I am going to split as the smaller power. Okay, so I can write it as 10 into 10 to the power 6, right? 10 into 10 to the power 6 is nothing but 10 to the power 7 because here power is 1 and if you use the product law, so 1 plus 6 will give you 7. Now 6.27 into 10 will be 62.7 into 10 to the power 6 kilometer. Now if you see planet A and planet B distance, I have converted as the same power of 10, right? So now I have to just compare the decimal values. So if you see 9.35 and 62.7. So obviously 9.35 is smaller, right? So from here I can write 9.35 into 10 to the power 6. This is smaller than 62.7 into 10 to the power 6. So whichever distance is less, it means that planet will be nearer to the Earth. So from here I can conclude that planet A is nearer to the Earth. Now question number 8. Mass of the Earth is 5.97 into 10 raised to the power 24 kg and mass of the Moon is 7.35 into 10 to the power 22 kg. What is the total mass of the two? So total mass if we have to find means we have to add both the mass, right? So mass of the Earth is given as this, mass of the Moon is given as this. We have to find the total mass. Now if the power of 10 will be same in both, then my work will be easier. I would have just added this decimal part and 10 to the power 22 will be common for both, right? But it is not same. So whenever you see such type of question, your first step is to make the power of 10 same. So in the previous question you have seen, right? The question was which planet is nearer to the Earth. For that also I have made their distance converted in such a way that power of 10 I made it equal. So here also I'm going to do that. So what I do, whichever power of 10 is more, I am going to write that in terms of the lower power of 10. So from here 5.97 into, if 10 to the power 24 I have to split as 10 to the power 22, I will be writing 10 square into 10 to the power 22, isn't it? Now see, base is same, so add the power 2 plus 22, it will give you 24, right? Base is same, so add the power 2 plus 22 is 24 only. So from here, now it will become 5.97 into 10 square is 100 into 10 to the power 22, and 5.97 into 100 will give me 597 into 10 to the power 22, isn't it? Now my power of 10 became same, isn't it? If you see here also 10 to the power 22, here also. Now I can add it. So the total mass will be, I will be writing it as 597 into 10 to the power 22 plus 7.35 into 10 to the power 22. And from here, if you can see that 10 to the power 22 is here also and here also, you can take it common, isn't it? So if you will take this as common, then what it will become? 10 to the power 22 into, here I will be left with 597 plus 7.35. So if I'm going to add it, so 10 to the power 22 into, this will give me 604.35. So the total mass will be 604.35 into 10 to the power 22 kg. So this will be the total mass. Okay. Now question number 9. The distance between Sun and Earth is 1.496 into 10 to the power 11 meter, and the distance between Earth and Moon is 3.84 into 10 to the power 8 meter. During solar eclipse, Moon comes in between Earth and Sun. At that time, what is the distance between Moon and Sun? So distance between Sun and Earth is given, distance between Earth and Moon is given, and you have to find during solar eclipse what is the distance between Moon and Sun. So let's draw the figure. Okay, so this is Sun here and this is Earth, and during solar eclipse Moon comes in between. So I have drew the diagram like this. Now whatever value it is given, I am going to write it. So distance between Sun and Earth is given as 1.496 into 10 to the power 11 meter, right? Then distance between Earth and Moon is given as 3.84 into 10 to the power 8 meter. And what you have to find? You have to find the distance between Sun and Moon. So when I drew the figure, now it will be very clear for you that what to do to find the distance between Sun and Moon, isn't it? It is, you have to subtract the distance between Moon and Earth from the distance between Sun and Earth, right? This total distance is given as this, and distance between Moon and Earth is given as this. So to find this remaining distance, you have to do the subtraction, right? So distance between Sun and Earth is given as this. Distance between Earth and Moon is given as this. Now to find the distance between Sun and Moon, you have to subtract their distance. But you can do the subtraction if the power of 10 will be same in both the case. But here it is 10 to the power 8, here it is 10 to the power 11. So again, always I say in such type of question, you have to make the power of 10 same, right? And what I usually do, whichever is having the higher power, that I am going to reduce in terms of the smaller power. So this I can write it as 1.496 into 10 to the power. Now it is 8. Now in 8, how much I will add to make it 11? 3, right? So 10 to the 10 cube to the power 10 into 10 to the power 8. Now if I multiply 1.496 into 10 cube, 10 cube is 1000. So if I multiply by 1000, I will get 1496 into 10 to the power 8 meter, right? And now I can easily subtract. So if I subtract it, I can see that 10 to the power 8 is common. So I will take it out, and then it will be 1496 minus 3.84. And if you are going to subtract it, you will get 10 to the power 8 into 1492.16, this much meter. And if you arrange it, it will be 1492.16 into 10 to the power 8 meter. So this will be your answer. Now if you can see here, when I drew the diagram, it became very easy, right? So whenever you solve these kind of word problem, wherever possible you can draw the diagram, please draw it. If your diagram is correct, it means your 70% work is done. Now question number 10. Express the product of 3.2 into 10 to the power 6 and 4.1 into 10 to the power minus 1 in the standard form. So first you have to find the product of both and then you have to convert in the standard form. And standard form, if you remember how to convert it, it should be written in the form of k into 10 to the power n, where k should be between 1 and 10, right? So let's see. So first you have to find the product of this. So if you multiply it here, 3.2 into 10 to the power 6 into 4.1 into 10 to the power minus 1, right? So if you write 3.2 into 10 to the power 6 into 4.1 into 10 to the power minus 1. Now I'm going to just arrange it. So 3.2 into 4.1 into 10 to the power 6 into 10 to the power minus 1. And if I multiply this 3.2 and 4.1, I will get 13.12. And here, as you can see, base is same. So add the power. So 6 plus minus 1. So this will give you 13.12 into 10 to the power 5. But this is not in the standard form. Because in a standard form, you have to write in the form of k into 10 to the power n, where this k should lie between 1 and 10, where 1 is included. It means it should be between 1 to 9.99. Okay, but 13.1 to 13 is more than 9.99, so I have to convert it. So this I can write as 1.312 into 10, isn't it? 13.12, if I write it like this, my value will remain same. It is 1.312 into 10 into 10 to the power 5. So this further I can write as 1.312 into 10 to the power 6, because base is same. So add the power. 1 plus 5 is 6. And you can see 1.318, this lies between 1 to 10, right? So this is my standard form. Now question number 11. Show that this is equal to 1. Now this is a very good question. It is asked in various competitive exams, even in IMO also. So in this question, you have to use exponents also, the concept of exponent, as well as the concept of algebraic identities. So let's see how to solve this question. So I will first take the LHS part. Okay, so in LHS part, if you see here, it is written x by m divided by x to the power n. So I am going to use the division law here because base is same and it is divided, right? So it will be x to the power m minus n. Okay, and this on top of that there is one more power m plus n. Same way, other one also I will write as n minus l whole n plus l. Okay, better put it this also in bracket. Now the third one, x to the power l minus m to the power of l plus m. Okay, now you have to use the power law. So power to the power, so you have to multiply the power, right? So it will become x to the power m minus n into m plus n. Okay, the other one will be x to the power n minus l into n plus l, and again it is multiplied with l minus m into l plus m. And if you remember the algebraic identities, where a minus b into a plus b, you are writing this as a square minus b square, right? So I'm going to use this identity over here. So it will become x to the power m square minus n square into x to the power n square minus l square into, this dot means it is multiplication, x to the power l square minus n square. Now again, if you see, the base is same and it is multiplied, so you have to use the product law. So x to the power m square minus n square plus n square minus l square plus l square minus m square. So plus m square and minus m square cancel out, minus n square plus n square cancel out, and minus l square plus l square is cancel out. So it will be x to the power 0, which is 1, and that is equal to your RHS, isn't it? So this question is very important question for many competitive exams. Even if you are preparing for, if someone is preparing for any government exams also, in there also these type of question comes in MCQ format. Okay. Hello, now question number 12. Here you have to find the value of x. So in such type of question, we know that if base is same in both LHS and RHS, then power will also be same. And like that, we can calculate the value of x. But if you see the base in LHS, one base is 12 by 13, another one is 13 by 12. And in RHS, base is 12 by 13. So our first step is to convert this 13 by 12 base as 12 by 13. So we have a law, right? We have one law which tells that if it is a by b whole raised to the power minus m, that we can write as b by a whole raised to the power m. So I'm going to write it here as 12 by 13 whole raised to the power 4 multiply by, now here it is a negative power, so I can write as 12 by 13 whole raised to the power 8, and this is equal to 12 by 13 whole raised to the power 2x. Now in LHS I can use the product law, so it will be 12 by 13 whole raised to the power 4 plus 8, that will be equal to 12 by 13 whole raised to the power 2x, and 4 plus 8 is 12, right? So if now base is same, so power will also be same, so I can write 4 plus 8 equal to 2x, and then I can write 2x will be equal to 12. I have swapped the LHS and RHS, so the value of x will be 12 divided by 2, which will give me 6. So 6 will be the answer. So that's all for today's class, and if you like my content, please subscribe my channel and share with your friends also. Thank you.